Astronomers say something unprecedented is unfolding right now. The interstellar object 3I Atlas is not just passing through, it may be controlling the motion of other comets. Only the third confirmed visitor from beyond our solar system, Atlas, is already an anomaly. But orbital data show alignments so precise that some experts believe its presence is more than coincidence. Physicist Michio Kaku has issued a warning. The odds of this clustering being random are vanishingly small. His concern is that Atlas may be exerting a hidden kind of control, subtle but undeniable in the way nearby objects are falling into rhythm with it. Its coma spans hundreds of thousands of kilometers, its chemistry unlike any comet on record, but its most unsettling trait is not its size or even its interstellar origin. It's the possibility that one alien visitor is shaping the timing of others. Is Atlas simply a cosmic outlier, or is this choreography by design? In most years, the inner solar system plays host to only a handful of comets bright enough to capture attention. The IAU's Minor Planet Center, which logs every confirmed discovery, shows that an average year may deliver one or two naked-eye comets at best, with most others detected only by large telescopes. The great surveys of the last 3 decades, Pan-STARRS in Hawaii, the Linear Project in New Mexico, and the Atlas Network itself have multiplied our cometary catalog. Yet despite this expanded watch, the pattern has always been scatter, not synchronization. That rhythm appears broken in late 2025. Several inbound comets from Swan to Lemon to K1 Atlas are arriving in compressed succession, their perihelion dates clustering within weeks of one another. Even more unsettling, the geometry of their orbits lines up closely with the path of 3I Atlas, the lone interstellar object among them. Instead of a random traffic jam, astronomers are charting something that looks choreographed. The clustering is too tight, the timing too compressed. Some specialists have begun to frame the anomaly around a single pivot, 3I Atlas. The suggestion is cautious, still marked as hypothesis. Yet in professional circles, the question has been raised, not just whether comets are arriving together, but whether one of them is acting as the anchor. To measure how unusual this is, astronomers have turned to the past. Before the age of robotic surveys, comet discoveries often came by accident. Bright visitors might flash across a photographic plate or be announced by an amateur scanning the dawn sky with binoculars. Records from the early 20th century show scattered arrivals, sometimes separated by decades, but almost never converging in the same season. The digital era changed the scale. Pan-STARRS, Linear, and Atlas have filled public logs with thousands of new entries. Yet in all those decades of data, no season has produced a cluster of comets bound to a single anchor object. Alignments have happened, but only in loose trickles stretched across years. The notion of multiple bodies moving in step with one interstellar visitor is unprecedented. Statistically, the odds are vanishingly small. The 2025 alignments push beyond what probability tables can comfortably explain. Scientists who prefer a conservative reading call it a rare outlier, a once-in-a-century convergence. Others argue that outlier is too weak a term, that the clustering has the hallmarks of something more deliberate, a choreography rather than a coincidence. Whether natural or not, the records are clear. Nothing like the 2025 pattern exists in the modern digital archive. The geometry of the swarm adds another layer of intrigue. Several of the comets, including Swan, Lemon, and K1 Atlas, follow paths that dip close to the sun on nearly the same ecliptic plane. Instead of spreading across the sky in random inclinations, they are threading the inner system along narrow corridors. From Earth's perspective, their perihelia appear unusually clustered, a choreography that places them near 3I Atlas itself. But the critical moment comes in late October, when 3I Atlas passes into superior conjunction. From Earth, the interstellar comet slips directly behind the sun, hidden in glare. For nearly 2 weeks, ground-based telescopes lose all access, a blackout window that erases our best opportunity to test the control hypothesis. Only space-based coronagraphs can bridge the gap. SOHO's LASCO C3 instrument and NASA's Twin Stereo spacecraft will continue recording faint traces near the solar corona. But these instruments are designed for large solar events, not the subtle perturbations that might signal influence. This timing unsettles astronomers. If Atlas truly exerts any effect, gravitational, electromagnetic, or something still unknown, its conjunction blackout arrives at the very moment when other comets cross perihelion. The stakes are obvious. What happens in the weeks when Earth cannot see? Do we miss the one signal that would prove or disprove the idea of influence? For researchers, October's blackout is more than an inconvenience. It is a silence in the record, a blank page in the very chapter they most want to read. And at the center of that missing chapter is 3I Atlas itself, a comet so strange it rewrites every baseline. 3I Atlas is unlike anything the inner solar system has seen in modern times. Its orbit is not elliptical, not bound to the sun at all, but hyperbolic. With an eccentricity greater than 1, it is passing through our neighborhood only once, never to return. That alone places it in a category shared only by Oumuamua in 2017 and Borisov in 2019, the two previous confirmed interstellar objects. But Atlas carries signatures that set it further apart. Size estimates vary from as small as 320 meters to as large as 5.6 kilometers across. More astonishing is its coma, the halo of gas and dust released as sunlight heats its surface. By late 2025, this coma is already measured at nearly 700,000 kilometers wide, approaching the scale of Jupiter. Spectroscopy from both Hubble and the James Webb Space Telescope reveals a chemistry that is just as alien. Where most comets are rich in water vapor, Atlas's outflow is dominated by carbon dioxide. Cyanide is present only in faint traces, while water itself is barely detectable. These are fingerprints of an origin beyond our system, material forged in another star's nursery. Compared to Oumuamua's puzzling acceleration and Borisov's ordinary comet-like behavior, Atlas sits between them, visibly cometary yet chemically alien, with a scale that dwarfs both predecessors. It is this combination, size, composition, and timing with nearby comets and small bodies, that has drawn warnings from experts. For some, Atlas is more than an interstellar visitor. It is the pivot around which an entire sequence of alignments is unfolding. Physicist Michio Kaku has not shied away from framing the anomaly in stark terms. In interviews and lectures, he has argued that the odds of Atlas's alignments with other comets and small bodies being random are vanishingly small. While he stresses that no one should leap to conclusions, he places the pattern in a category of events that demand serious attention. Kaku's language is careful but weighted. He notes that gravitational influence from a body like Atlas should be negligible at astronomical distances, yet the synchronized timing of perihelia, the clustering along the ecliptic, and the compressed calendar of arrivals together suggest more than accident. His warning, that Atlas may be exerting an influence through means not yet identified that is reshaping the trajectories of nearby objects. He calls it a hypothesis, not a conclusion, but the implications are profound. If interstellar objects can alter the dynamics of local comets and meteors, our current models of celestial mechanics are incomplete. More troubling, it raises the prospect that Earth's planetary defense strategies, designed to track random, independent threats, might miss coordinated patterns altogether. For Kaku, the lesson is not alarm, but humility. We may be witnessing a phenomenon that forces us to rethink our assumptions about what comets are and what they can do. His words place 3I Atlas in a category of cosmic unknowns, a reminder that the universe is not always bound by the probabilities we take for granted. If Kaku's warning seems abstract, the observational evidence gives it shape. By late 2025, multiple comets are threading the inner solar system in close succession. C2025 R2 Swan, C2025 K1 Atlas, and C2025 A6 Lemon among them. Each has its own source region, yet their perihelion dates fall within weeks of 3I Atlas itself. Swan sweeps closest to Earth on October 21st, barely a week before Atlas itself rounds the sun. Lemon reaches its brightest in early November, overlapping the interstellar object's outbound path. K1 Atlas dives toward perihelion in early October, marking the opening act in the sequence. Instead of a loose scattering, the objects appear bunched together, their choreography unsettlingly precise. The inclinations of their orbits add to the strangeness. Several hug the ecliptic Earth's orbital plane, rather than dispersing across random angles. This shared geometry makes their alignment with Atlas harder to dismiss. To observers charting their paths, the comets look less like independent wanderers and more like dancers following a lead. Some speculate that resonance or plasma interactions from Atlas's vast coma could be imparting subtle nudges. Others describe the pattern as echoes, meteors falling into rhythm with an unseen metronome. Mainstream astronomers remain cautious. They argue that improved surveys catch more comets and that solar maximum naturally produces more visible activity. To them, the alignments are statistical quirks amplified by observation, not control. Yet the data are clear. Multiple comets arriving in lockstep with an interstellar body is not something recorded before. Whether coincidence or choreography, the sky of 2025 is writing a script we have not read before. The question is how. What possible mechanism could allow one interstellar object to guide others? Mainstream mechanics say that 3I Atlas should not have the power to alter the orbits of other comets. Its gravity, while measurable near its own nucleus, is far too weak to affect bodies millions of kilometers away. On paper, the equations close the case. Atlas is just another visitor. But some researchers are testing more unconventional hypotheses. One pathway involves plasma interactions. Atlas's enormous coma, dominated by carbon dioxide, is electrically active. As the solar wind collides with this expanding envelope, it creates magnetic draping structures, tangled field lines that could, in theory, ripple into nearby space. Another hypothesis involves solar wind redirection. If Atlas's coma is large enough, it could locally divert streams of plasma, altering conditions for smaller bodies downstream. Like a boulder in a river, it might create turbulence that affects the flow far beyond its size. A third speculative mechanism is resonance across debris fields. By passing near the heliospheric current sheet, Atlas may trigger instabilities that ripple outward, influencing the trajectories of dust and fragments that intersect with other comets. The CCMC's magnetohydrodynamic (MHD) simulations hint at these possibilities. Models show that large comets crossing through solar current sheets can seed turbulence, sometimes strong enough to cause disconnection events in their own tails. Extending this logic to Atlas is still unproven, but it is a testable hypothesis. For now, the physics of influence remain theoretical. Gravity alone cannot explain the patterns. Plasma and resonance effects remain speculative. But the scale of Atlas's coma and the precision of the clustering invite the question, are we seeing more than chance at work? Within research agencies, the question of Atlas's influence has sparked sharp division. At NASA's Community Coordinated Modeling Center, CCMC, simulations suggest that comet plasma can nudge solar instabilities. Their teams argue that with Atlas's coma approaching planetary scale, the chance of downstream effects rises. In internal papers, they highlight October and November 2025 as critical windows for testing the hypothesis. By contrast, scientists with the Parker Solar Probe and ESA's Solar Orbiter present a more conservative view. Their in-situ measurements show comet tails behaving largely as passive tracers, shaped by the solar wind rather than shaping it. In their analysis, even large comets are swept along rather than steering conditions. They see no evidence that Atlas could influence other bodies across astronomical distances. Agencies have indicated heightened monitoring during the conjunction window or label as unconfirmed reports. A briefing circulated among space weather officials in September 2025 warns of increased uncertainty in plasma interactions and directs observatories to maintain round-the-clock tracking. The language is careful, but the implication is clear. While officials dismiss public speculation, behind the scenes they are not ruling it out. The looming blackout window adds urgency. When Atlas passes behind the Sun in late October, Earth-based observatories will lose direct sight. For roughly 2 weeks, the world will depend on coronagraph feeds from SOHO and Stereo. The fear within agencies is simple, that the key event, the definitive perturbation, may occur during those hidden days. Between public caution and private concern, the debate exposes a fracture. To some, Atlas is just another comet. To others, it is an unknown operating at scales we have yet to measure. One of the strongest lines of evidence for influence would be a synchronous outburst. Multiple comets flaring in brightness within the same narrow window of time as 3I Atlas's key orbital passages. In recent months, astronomers have flagged unusual brightening episodes in C2025 R2 Swan and early activity in C2025 A6 Lemon. While each can be explained by natural processes, volatile pockets exposed by solar heating or fractures within the nucleus, the timing has drawn interest. Both flares occurred within days of Atlas crossing the ecliptic plane. So far, no consensus exists on whether these are related. Mainstream interpretations treat them as coincidence, reminders that comets are inherently unstable. Yet speculative analysis points to the possibility of a trigger. If Atlas's vast plasma sheath can alter solar wind flow, smaller comets passing through downstream corridors might experience sudden surges in ionization, igniting outbursts. Forecasts for October and November now highlight the potential for synchronous flares as Atlas nears perihelion. Observatories worldwide are bracing for coordinated campaigns to catch any such events in real time. Skeptics remind us that outbursts happen often and that statistical clustering can trick even careful observers into seeing patterns where none exist. Still, if multiple comets flare within hours of one another while Atlas is hidden in conjunction, the debate will sharpen. Whether coincidence or correlation, these outbursts have become the front line in testing whether Atlas is acting as more than a passive traveler. But the first hints of an answer may not come from massive observatories at all, but from a lone telescope in Spain. Beyond the models and debates, the mystery of 3I Atlas has already played out through the eyes of individual observers. In October 2025, just before Atlas slipped into conjunction, a network of amateur astronomers logged curious changes in the tail of C-2025 R2 Swan. Among them was an observer in southern Spain, whose backyard telescope captured a sequence of images showing the ion tail bending sharply within hours. On its own, this could be dismissed as solar wind turbulence, the kind of variability seen many times before. But what unsettled astronomers was the timing. The twist occurred within a day of Atlas crossing the heliospheric current sheet, a boundary in the solar wind where magnetic polarity reverses. The report was filed with the Minor Planet Center and circulated informally among professional teams. Some dismissed it as coincidence, the product of a small telescope pushed to its limits. Others, however, noted that similar bends appeared in independent images from observatories in Chile and Australia, suggesting the event was genuine. For the Spanish observer, it was a moment of awe mixed with unease. "I felt like I was watching something respond to an unseen signal," he later wrote. Whether natural or not, the data entered the growing record of anomalies clustering around Atlas's approach. If the influence hypothesis is correct, it may not be the world's largest observatories that detect the first proof, but the patient eyes of amateurs tracking the sky each clear night. Some researchers have asked whether 3I Atlas is doing more than just guiding through geometry. Could it be emitting signals? The idea may sound extreme, but it echoes debates surrounding Oumuamua in 2017, when unexplained non-gravitational acceleration led a few astronomers to consider engineered origins. Atlas's vast coma provides another puzzle. With a halo hundreds of thousands of kilometers across, any emissions, thermal, radio, or otherwise, would be difficult to distinguish from natural outgassing. Yet radio observatories have begun quiet campaigns. Facilities like the Green Bank Telescope in West Virginia and the Allen Telescope Array in California have been tasked with monitoring Atlas during perihelion. So far, nothing beyond. Background noise has been confirmed. Still, speculative models suggest the alignments themselves may serve as a kind of symbolic signal. Perihelion passages choreographed like pulses, each comet echoing a beat in a sequence. Whether this is coincidence or intentional design, the pattern is enough to draw attention. The counterpoint remains strong. No verified signals have been detected. Every outburst, every flare, and every drift can be explained by natural processes. But the possibility that Atlas's choreography is deliberate keeps the question alive. As one researcher put it, absence of evidence is not evidence of absence. For the public, the 2025 season offers rare chances to see the mystery firsthand. The first key date is October 21st, when C-2025 R2 Swan makes its closest approach to Earth, passing within 0.25 astronomical units, about 37 million kilometers. Even a modest pair of binoculars should reveal a tail stretching several degrees across the dawn sky. The second highlight comes in early November, when C-2025 A6 Lemon reaches peak brightness. Forecasts suggest a magnitude of 3.5 to 4, making it visible to the naked eye from dark sites. From November 6 through 12, northern observers will find it glowing low in the southwest after sunset, its coma and tail lengthening nightly. For the comets hidden near the sun, space-based instruments provide the view. SOHO's LASCO C3 coronagraph and NASA's Stereo spacecraft stream live images online, open for anyone to examine. Outbursts, disconnections, or unexplained perturbations may first be spotted by ordinary citizens scanning these feeds. This is where the role of citizen science becomes critical. Small anomalies in brightness or trajectory logged by amateurs could become the data points that settle the question of Atlas's influence. In 2025, the sky itself becomes a global laboratory. While the climax of Atlas's story unfolds in late 2025, astronomers are already looking to the year ahead. That is when Earth may pass through portions of the interstellar object's dust trail, debris shed as the nucleus heats and fractures near perihelion. The encounter is forecast for mid-2026, though the exact density of particles remains uncertain. For planetary defense teams, this crossing is both an opportunity and a risk. On the scientific side, it offers the chance to study alien material up close, fragments that were forged around another star before drifting into our system. Meteor showers generated by the trail could deposit particles in Earth's atmosphere, where specialized radar and collection missions might recover them for laboratory study. But the scenario carries hazards as well. If the trail contains denser clusters of fragments, Earth could face micrometeoroid storms, disruptive to satellites and potentially hazardous to crewed missions in orbit. Space weather forecasts are already incorporating Atlas's path into their 2026 risk models. Speculative voices raise a further question. If Atlas is orchestrating alignments, could the 2026 crossing itself be part of the choreography? A deliberate placement of interstellar material across Earth's path? It remains only a hypothesis, but one that adds weight to the urgency of monitoring. For now, 2026 is marked on calendars worldwide. Whether it brings a benign light show or the first interstellar samples ever collected, Atlas's influence will not end with its passage around the Sun. The true test may lie in what its trail leaves behind. By year's end, the outlines of the story are clear. 3II Atlas is an interstellar object, chemically distinct with a coma nearly the size of a planet. It is a one-time visitor, following a hyperbolic path that confirms its alien origin, and yet its timing coincides with a clustering of other comets that appears far from random. The anomaly lies not just in its chemistry or scale, but in the synchrony of arrivals around it. Swan, Lemon, and K1 Atlas all crowd the calendar within weeks of its perihelion. Their inclinations hug the ecliptic plane, their approaches compressed. To many, the pattern resembles choreography, not coincidence. The stakes reach beyond astronomy. If the clustering is a natural fluke, it is a reminder of the universe's capacity for rare wonders. If it is more, if Atlas is truly guiding or influencing, then it forces a new question. What role do interstellar visitors play in shaping our system? Binary framing captures the uncertainty. Either Atlas is an improbable accident or it is something else, built, not born. As the blackout window closes and the comets continue their passage, one truth remains. 3I, Atlas has already changed how astronomers think about interstellar visitors. Whether coincidence or choreography, it has forced the question of control into the open. For viewers, the story is not just unfolding in laboratories and observatories, but in the sky above. Each clear night is a chance to witness history, to document anomalies, and to contribute to a record that may alter our understanding of the solar system. So stay tuned, subscribe for continuing coverage, and if you have the tools, join the watch. Because the real question is not whether Atlas is interstellar, that is already certain. The real question is whether it is acting alone. And if this is choreography, then the next movement may already be underway.